right, hello and welcome to the simulation topic where we are just going to run through some extra problems to get a complete picture of how to implement your simulation model into Excel. We're going to look at problem 1 first, of course, and let's just read it together. Understand that you can pause the video, of course, if you need to read it again and double check things. You don't have to just be able to read it once. All right. Harry's Auto Shop has observed monthly demand for tires over the last 60 months according to the table below. So we got some frequencies there of how many times these different demand values occurred, how many he wants to sell or he can sell. Harry estimates that his average selling price per tire each month follows a discrete uniform distribution between $60 and $80 whole dollar amounts. Harry's variable cost per tire also varies each month depending on material costs and other market conditions. This causes Harry's average profit margin per tire, percentage of the selling price, to vary each month. Using past data, Harry estimates that his profit margin per tire follows a continuous uniform distribution between 20 and 30%. So those can be decimals. Harry estimates that his fixed cost of stocking and selling tires is always $2,000 a month. All right, so let's see here. What do we want to do? We want to set up in Excel a simulation over 200 months, and then some other questions, but one thing at a time. So I have some of these things set up already just to have a plan of what to do. These columns might not be perfect the first time you set them up. You might need to add some. You might find that, oh, some of these are unnecessary, but just to have an idea. We're going to have to generate a demand value. Actually, I'm going to insert a column here because we need to do this 200 months. So I am going to have maybe the month number here as well. And it'll be month 1, 2, 3, and so on. So add and remove columns as you get a better idea of the problem. So we're going to use a random number to generate a demand value. We have our selling price. Maybe I want to keep track of that because that is selling price is going to be between $60 and $80. Then we are going to use another random number to determine the profit that he's making. And that ranges from 20 to 30%, uniform distribution there. And he has his fixed cost. And then we want to calculate the profit ultimately. So we want to use these cells to help us determine the profit, which is what we eventually want to have for the simulation. So because this is our first one that I'm doing with you, I want to take my time and make it as clear as possible. We're not in a hurry. We might speed up the other examples. Okay, so I can just write in here $2,000 for profit, right? Because that is not going to change. Excuse me. Got all choked up that it's not going to change. It's so easy. So you may or may not need a column for that, but just to be clear, we'll have our profit over there. So the first issue, I'm going to go just make it easier and start with the selling price. Selling price first. Let's zoom in. Excel has a built-in function when we want to find an integer value within a range, discrete uniform distribution. It has a built-in function to do that. It is the function that I'll search here to let the helper guide me. Rand between. I can search for it. There it is. And it'll guide me for how to set this up. The bottom boundary is 60, the top boundary is 80, and it is as simple as that. And if I rerun the whole spreadsheet, I'll see that it's giving me random numbers every time within that range. Okay. So that's one we can very quickly do. Rand between for a discrete uniform distribution. Next, I'm going to do the profit margin, just because the demand is the hardest one when I build up to it. I'm going to take a random number, and for this first example, I want to see the random number. The function that gives me a random number is rand with open and close brackets. You see, if I press on a Windows laptop, I have F9. To recalculate, I press F9 every single time to recalculate all these cells, all these formulas. It gives me a random number between 0 and 1 every time. Now I want to use that, as the question says, to get a continuous, or to draw out of a continuous uniform distribution between 20 and 30%. Now we are going to do that with a simple calculation. Our bottom boundary value plus the random number applied to, I'm going to do it in detail, though you don't have to. You could just write 10 here, the length of the boundary. I get 10 by saying 30 minus 20. So I'm going to start from the left side and step into that interval a certain length from nothing to all the way up to the other end. So I'm scaling the length of the interval. So this is going to be a percentage. I can, of course, I have to remember that this is now a percentage. Maybe I want to, I don't use as a rule the percentage format, because it sometimes does calculations that you forget about and then you're off by something, and it's just in general a bad idea in my experience. If I want to remember this is a percentage, I'll put the percentage sign there to remind myself, hey, this is a percentage. So when I do a calculation, I still have to manually divide it by 100. That is just much safer. When I use the percentage format, which is here, of course, percentage over there, it does the multiplication and division of 100 for me sometimes, and it's just not, it doesn't work for me, but you could feel differently. All right, so we have our selling price with the rand between function. We have our profit margin from a continuous uniform distribution. All is well so far. Now for the demand. I'm going to use a random number. That's how I generate a random number for my demand. Now, how do I actually do it? Well, let's scoochie on over here to the left. No, that's the wrong side. The right. And realize that I have frequencies that I've put in here. You can add them up if you want to. Let's get the sum function going here. Let's see how many samples we have for previous month, 60, or 60 occurrences of a sale, or I guess no, 60 months, yeah. So our probability is simply going to be the frequency divided by the total, which I can fix, of course, because the total is not going anywhere, also called the relative frequency. The relative frequencies are used as approximations to the actual probabilities, which I don't really know. I don't know the distribution. Why are there always all of them 0.05? That's obviously not right. Nothing gets calculated until I manually do it. because we have set in Excel, if I go to my options and formulas, I have set it to do manual calculations. Otherwise, the random numbers keep changing, and all the numbers just keep changing, and it's very weird. So I just have to then remember whenever I do anything, manually press it to actually perform the calculations. So if I just scooch here a little bit, if I think about the range of the probabilities from 0 to 1 that should return to me these different demand values, the lower end of the first one starts at 0, and then I'm going to manually put it in for us to get used to it, and ends at 0.05. The other one starts at 0.05 and ends at the total of these two, which would be 0.15. It has a range. It has a little bucket range that it's trying to catch random numbers in when they fall between these two. Now don't worry too much. The upper one is not actually included, but for simplicity, we make them the same. It's included in the bottom one. However, next one's going to start at 0.15 and then go up to 0.35, a little 0.2 bucket that is going to correspond to a demand of 340. Then I start at 0.35 and go up to 0.65. Next one will be 0.65 all the way to 0.9. Whoopsie, just 9. And lastly, 0.92, of course, 1. From 0 to 1. I have to have every probability in here somewhere. Okay. So now, how do we extract a demand value that corresponds to a random number? So for example, the random number I have here is 0.59 something something something. So I want that which bucket does that fall into? It falls into this one, right? So that means that I want Excel to go and look which bucket is it, then return the corresponding demand value. I can easily do that with a lookup function. In some books, you might see the lookup function being used. It's apparently an older version of the function, which in future versions of Excel might not be continued. So we're going to use an updated one, the Vlookup function. However, there's one little catch, not a big one, just one thing to be aware of. When I look into my buckets and I ask Excel to return for me the number in the row, it cannot look backwards. It only looks forward. So all I'm going to do is copy the demand value to be further to the right of these bucket values. That is just how the Vlookup function unfortunately works. Don't ask me why. So here I'm going to insert a function, and it's going to be Vlookup. I know it's already in my list, but there it is. It's going to guide me through the process here. I want to look up a value that is my random number. And I'm going to look it up in this table, spanning from the lower limits to the demand that I copied on the right. When it finds which bucket my number belongs to, I want it to return the third column in the selection. This was my table selection. It's going to find that 0.597 something falls into this bucket. It's looking to the right, and it's going to return 360. Maybe not perfectly, because I'm going to have to recalculate. We'll see. So it's the third value in that row, the third cell. Let's do it. Oh, it does it. Great. I thought I was going to have to recalculate. Let's recalculate a couple of times, though. If I have 0.083, which bucket does that fall into? The second one, 320. 0.3513 falls into this bucket here, 360, and you can keep calculating. It'll eventually convince you that it's doing the right thing. Okay, so the Vlookup function, very handy, with a little itty bitty catch that the number it should return should be further to the right. Not a problem. I just copy it over. Okay, no big deal there. Okay, so far so good, I hope. So now what do we have? Now in truth, we don't need to see the random numbers, right? We use them in here, but in future examples, we may drop this column to not have it be too busy. But for now, it's our first example from my point of view, so I'm going to leave them in there. Okay. So now I want to calculate my profit. Now excuse me, let's see here. So we are selling this demand value of 360 tires in month 1. Our selling price is $74. We make a profit of, in this case, a little over 20%. Nice. And we have a fixed cost. So how can we calculate the profit that we're making? Notice that I don't actually care about the revenue, right? I'm only interested in the profit. If you look carefully here, what I'm interested in ultimately calculating in my simulation is the profit. So the most important thing here is the profit margin above my selling price. Let's see here. Selling price was also changing. Okay, so the profit that I'm making in this example in month 1 is roughly 20% of 74 per tire. That's the profit. So I understand it's a little, maybe a little unclear in this question, but I'm using it to illustrate the simulation, a test question, things like that, where you're on your own. I'll make sure that it is perfectly clear. So we have 360 tires, but we can't type that in. We have to reference the cell. 360. And for each of those tires, we're making a percentage, which I choose to manually divide it. It's my choice. It's not the only way to do it. Percentage of the selling price is our profit. And we have a fixed cost to do that, which is over here. So our profit for month 1, based on these numbers, is a little over 3,000. I can then take all of these and copy them down. I'm not going to copy them down too far. I just want to see a few and make sure that my formulas work. I recalculate. Ooh, something went wrong there. Let's see what that is. What happened? Ooh, the demand value is weird, right? So it's a good idea to just copy a few rows and then double check your formulas. I did this one on purpose to show you how easily it can happen. Don't go and copy 200 months, which we ultimately want to do, until you're sure your formulas are doing what they should. So I can check here. What does this formula do? Not the right thing. This isn't the correct table anymore because I forgot to, not that one, to fix my table selection. So I go in there, it's the pink one here, F4, F4, now it's fixed. So let me copy those again and then recalculate. And it looks much better. I'm not getting not applicable numbers. Still good to maybe check. Yeah, okay, further down, it's still using that. It's looking at the right number. Selling price is just a random number in between 60 and 80. Random number there. Profit margin is using that write that correct random number. Ooh, the fixed cost isn't right either. Excel thought I was looking for a pattern. I am not looking for a pattern. I'm good. So maybe a few of them and Excel will realize, whoa, okay, you want the same 2000 every time. Oh, okay, you don't want to increase it by 1. There we go. Okay, that's better. All these little things, don't do too many, and make sure your formulas work first. Now I feel more confident. I'll copy it down to 200. I don't know where that is going to be. We keep going. We keep going. Let's stop over here somewhere. We see, ooh, we overshot it. Not a big deal. I will just delete the extra rows. Boom. Okay. So it's not go up. You have to include every one of these rows, nothing else. You have flexibility. Show enough detail for you to help yourself, for you to keep track of how you calculate the profit, as well as for someone else that may look at it, of course, right? Okay. So ultimately, we want the average monthly profit, standard deviation of the profit, and so on. What we could do for the average, let's say, we have an average function, right? Average, I can do it in line. I can do it with the function. When I have a big selection like this, maybe using the insert function is a little bit nicer. It's there for to be user-friendly, so why don't I use it in that way? I'm selecting all my profit values, and what's nice is I can see the selection as I'm dragging all over the place. Where is the end to this? It's a little much, isn't it? There we go. Done. Scroll. It jumps me up to the top. That's nice. Now you'll see that this changes as I recalculate, because everything gets recalculated as well as the average. But you'll see that even though from month to month in my simulation, I have 4,500, then I have just below 4,000, then a 2,400 month. Ooh, that was a little low. Ooh, 6,300 month. There's a lot more fluctuations here than if I looked at how much the averages fluctuate from one to the next. They're pretty stable, right? And if you remember statistics, of course, the distribution of means has a much smaller standard deviation, or called the standard error. But anyway, that's a side note here. Let's see if we have a built-in function for standard deviation. What shall I search here? Standard deviation. There's a lot of options here. Maybe it confuses you a little bit. I don't know. I'll show you a much better way to get that and much more. So we can ask Excel by way of the data analysis tool pack to find all the statistics that I might want. When I open that, I have descriptive statistics. I'm just going to cancel this for a second because I realize not everyone might have this under the data tab. What do? You install it the same way you do Solver. I go to my options. I go to add-ins. I go at the bottom, go. And then I just make sure the analysis tool pack is selected. Then when you click on the data tab, it should be there. I now select it so you can follow along. There are many things here I can do. I want descriptive statistics. And then, of course, what is the input? Well, all the profit values. The nice thing about newer Excels is I could drag it down a lot. When it senses it's coming close to the end, it'll slow down for me. It's so nice, so nice. These little things that the original early versions of Excel did not have. If you go down too fast, it'll just fly past it by like 1,000 rows. And then you have to backtrack. Oh, it was bad. Alrighty, let's say here I want to put the output just below there. Let's say right there, put it right there for me. You can choose a new worksheet, whatever. Summary statistics, sure, give me some summary statistics. Go. It's going to calculate. You see the average that I calculated was the same. Now, of course, this is a one-time calculation. If I recalculate, it doesn't recalculate for me. But what does that matter? Standard deviation is over here. The standard error is the distribution of means. Let me just move this a little so you can see the wording. Oh, I didn't need to move it that much. There we go. So the standard deviation of the distribution of the profit values is this one. So what you could do is you could just copy that in, and then it's never going to change either, which is kind of nice. But it's the same as if I just pressed F9 a bunch of times and decided to stop randomly, right? It's whatever snapshot you're looking at. It's a little randomly a little high, but whatever. It could happen. 58.55. And you can then use this. If I have enough replications, 200 may not be enough, then the distribution will tend towards a normal distribution, and the standard deviation can be used to approximate further properties of that. We have things like kurtosis and skewness and all kinds of things. If you're interested, or if you're not, you can just delete those rows, right? The median, the mode isn't applicable because no number repeats, and so on. So you have a bunch of stuff. You select from it whatever you want. It's all good. Okay, so there's an indication of simulation for 200 months. Now we in Excel can't go too big because it slows it down a little bit. So I know 200 realistically is not enough to really get that standard error nice and low. But then the recalculation takes a long time. So 200 is sort of a sweet spot that doesn't hold us back time-wise. So that's A. Actually B as well. Estimate the average monthly profit, standard deviation of the monthly profit. We did that. You can organize this and make it look pretty if you want to, although it's kind of pretty already. Then we have a question here. I want to use my simulation to estimate the probability that the monthly profit will be at least 4,000. So we have 200 profit values that we've generated, right? What we could do is simply count how many have this property that we're looking for, being at least 4,000, and then once we count those, divide it by 200, how many there are. So you don't have to separate these two, but just for the sake of clarity, I did. Let's look for a function. Well, I want to count stuff. The function we're looking for is COUNTIF. Counts the number of cells within a range that meet the given condition. Yes, that sounds appropriate. So what's my range? All the profit values. See, I go down, wee, but it slows down for me when I get really close. It's so nice. Criteria is I want to be greater than or equal to 4,000. I'll apologize if that's a little small. I can't zoom in on that text there. And we get 112. Of course, that changes as I recalculate, right? And because 200 is not really enough, the number has quite a bit of variability behind it, unfortunately. So then the profit is simply that number of months over the total. And I get 0.61. You can change that to a percentage if you want to. Do whatever you like with it. 61%. Roughly, it's going to fluctuate around 60, it seems like. In practice, if I want to be more precise, I'm going to have to just run this much for more repetitions. But then it takes a while to actually finish, and we want to just do it quickly like this. So do understand that 200 is not enough. All right, there we go. That is our first example. Now, leading into the next one, I want to quickly give an alternative to calculate this average. It's not necessary here, but in more complicated situations, we might not have the space we do here to run all these repetitions. It took a lot of space. Let's get rid of that. What can I do? Sometimes we'll see in a couple of examples, I need all this space to create one simulation value. How do I repeat that whole block 200 times? It just does not work. So what can we do? What can we do? Well, we're going to make a data table. I'm going to do it on the right here to show that I don't need all that space, but I do need something, of course. I'm going to make what we call a data table. I'm doing the same thing, but we'll soon see that it is more space efficient. Let's just make this a number, my run number or my replication number. And then here will be the profit. In this case, we're interested in profit. So I'm going to just number these 1, 2, 3, and so on. This is just my habit. I like green cells for formula output, but that's just my habit. That's how I learned it for the first time. Now I still want 200, right? I'm not going to get around that. I'm looking at the row counter. It's roughly going to stop over here somewhere. Ooh, wow. Look at that. Look at that. I perfectly randomly stopped at 200 exactly. Wow. Wow. Am I the only one impressed by that? It doesn't slow me down until I have it. Then if I go super fast, it slows down. That was a total fluke. Wow. Awesome. It's the little things that matter. So now for the profit, I'm just going to reference 1 month's worth of profit. It's this guy over here, right? I need to do the whole thing once, but only once. And of course, it changes as the random numbers change. So now I'm going to select all of this. Go, go, go. Slow down. There we go. And select data. What if analysis, data table. Okay, now what the data table is going to do is essentially what we just did on the right, except it's going to recalculate, take the profit value, put it into replication number 2. Recalculate, put it in for replication number 3. It's just going to do all of it for me. I don't need to see all those columns. I am making a column of data values, so it's important to put your cell in the column input cell. Now, data table actually does more than we need it to do. What it actually does is it takes these 1, 2, 3, 4, 5, 6, 7 numbers, the rep number, it inputs it somewhere as if it doesn't know what we want to do. It inputs it somewhere thinking it's input that is important. It is not important for us because we've independently from these numbers calculated the profit. So we're just going to give it a blank cell so it can just throw numbers in there. Those numbers don't actually matter to us. We just want things to repeat for our purposes. It doesn't know what our purposes are. So what it's going to do, of course, we have to actually calculate it, right? What it's going to do is it's going to take number 2, put it in there. That's the cell we chose. Let's make it purple. Why? Because I can. Or maybe not purple. That's a purple. No, that's gray. I don't know what that is. Anyway, it's going to take the number 2, put it in there, thinking it matters. No, it doesn't. We already calculate the profit separately, completely independent. Calculate that, put it in there. Do it again, put it in there, put it in there, put it in there. Okay. It's doing exactly the same thing. And now we could say, for example, we could run our descriptive statistics on that. We can do the average manually from our data table. It is the same thing. However, it is more space efficient. That is all. As that changes, you'll see this changes and so on. Because for more complicated situations, I need all this space to create one replication. I can't duplicate a whole block 200 times. We were lucky in this example because we only need a little row to complete a replication. And then we can do that 200 times. Yes, but in many cases you can't. The data table is an alternative when I don't have the space necessarily. In the next example, we'll see that happening. For now, it is an option that in a simple question you may or may not want to take. In more complicated situations, you don't have a choice. Okay, so rewatch it, get a handle on how this works. We don't use all of it in the way it was necessarily intended completely. It can do more than what we need it to do, but it's sufficient for our purposes. We have more examples. There's more, but I'll break them up one video at a time. Hopefully this has made sense. And if it does, you can move on to the next one. Until then.